welcome to your notes on writing parallel and perpendicular equations. So first we have to identify what it is we are doing. So with this, in this foldable in these notes, we're going to be given an equation to start with. This is going to be our original equation. It could be in slope-intercept form, so y equals mx plus b. And it could be in standard form, so ax plus by equals c. From that equation, we must use some information from that to create another or a second equation. So we're going to have an original one, and we're creating a new one from that. That is either parallel or perpendicular to that original line through some certain point that is going to be given to us. So our new line must be passing through that. And remember, a point given to us with coordinates x and y. Keep in mind what you already know about parallel and perpendicular lines. So one of those things that we already know is that parallel equations have the same slope. So if we're finding two lines, that slope that they have is equal to each other. With perpendicular equations, they have opposite reciprocals for their slopes, which again just means that the fraction of their slope is flipped and the sign is also changed between those. So now you're going to go ahead and open your notes, please. Alright, your notes should be open to writing parallel equations. We're going to be starting with example number 1. So first, highlighting some important information, we're going to create a new equation of a line that passes through a particular point that is parallel to this equation that is already given to us. So what we're doing is we're writing a new equation. We're not using that one given. We are going to take one piece of information from that. Because our lines have to be parallel, we need to use the same slope when we write our new one. And in the one we're given, y equals mx plus b, negative 4 is the slope. So negative 4 is the m value that we're going to be using, in addition to the point that we are given, negative 2, 7. So using that, and using only the slope from that equation and the point we have, we do need to use point-slope form, which is y minus y1 equals m times x minus x1. And then the information that we have being plugged in there, we're going to plug in the y-coordinate of our point. So in this case, that y-coordinate is 7. And that's going to go in place of y1. That is equal to m, or our slope, and remember our slope is negative 4. It's the same as the original, times x minus x1, and x1 is the x-coordinate, or negative 2, of the point that we were given. The next thing that we need to do is finish simplifying this by first distributing on the right side as well as getting rid of those two negative signs. So negative 4 times x is negative 4x, and negative 4 times a positive 2 is going to give us a negative 8 on the right side of our equation. In the end, we want y by itself, so we need to add 7 to both sides of this equation, and doing that gets y isolated on the left side, so we end up with y equals negative 4x, and negative 8 plus 7 gives us minus 1. So our new equation is y equals negative 4x minus 1. We're now going to look at example number 2. And again, we're going to be writing an equation through this point, 3, -1. And again, it's going to be parallel to our given equation, which means that we need to use the same slope as the original one that we were starting with. And looking at the equation we have, x minus 3y equals 9, it does look a little bit different than the one in the last example, and that is because it doesn't have the slope shown to us. That equation is in standard form. So we have to do a little work to find the slope, which is the one piece of information that we want from that equation. So the first step, we need to isolate the y term to get it into slope-intercept form. So we're going to take x away from both sides. So we have -3y left over on the left side, and that is equal to -x or -1x. And then we still have that +9 that was also there on the right side. We still need to isolate the y term, so we're going to divide everything by a -3 to undo that coefficient. On the left, we end up with just y. On the right side, we have -1 divided by -3, which is +1/3 x, and 9 divided by -3 is -3. So remember, we only wanted the slope from that equation. We only wanted 1/3. So that's the slope that we're going to use for this line. We don't need any other piece of information from that equation. Now that we have that slope, so m equals 1/3, and we have a point that was given to us, that 3, -1, we're still going to use point slope form like we had used in the last example, which was y minus y1 equals m times x minus x1. So we're using the x and y coordinate from our point and the slope. So first plugging in the y coordinate of -1, then going ahead and plugging in our slope that we found, which was that +1/3, and then plugging in the x coordinate of our point, which was that +3, in place of x1 in that equation. The next step, again, is to simplify. So any minus, we're going to simplify that first. So the left side is y plus 1. On the right side, we're going to distribute that 1/3. And 1/3 times -3 is -1. And we still want our final equation in slope-intercept form. So y equals mx plus b. So we're going to subtract 1 from both sides to isolate the y variable. And doing that, we get y equals 1/3 x, and then -1 minus 1 is going to give us -2. So we used our original for the slope and created this new equation that is parallel to the original one. Go ahead and on the left side, try the you try question starting with example number 1.